This time we want to know if it's true or false. Is it true that if x and y are vectors that are perpendicular, that means they form a 90-degree angle, or what we call orthogonal, then is it the case that the dot product of x and y is 0? And it's true. Let's prove it. Notice if they form a right angle or they're perpendicular to one another, we actually can form the sum of these two vectors, or the resultant vector would be x plus y, and it forms a right triangle. We also know by Pythagorean theorem that the length of vector x plus the length of vector y, the length of vector x squared plus the length of vector y squared would be the length of the hypotenuse of this right triangle, or the length of x plus y squared. In other words, if we looked at the length of vector x squared, which would be the dot product of x with itself, and added to it the length of vector y, which is its dot product with itself, we should get the dot product of x plus y with itself because of Pythagorean. But I'm going to use this symbol, which means equivalent. These two sentences are equivalent, or expressions are equivalent to one another. This would mean that x transpose x plus y transpose y would be equal to, from our last homework, we know this is always x transpose x plus 2 times x transpose y plus y transpose y. But if these two are exactly equal to one another, that would mean that 2 times x transpose y would have to be 0, or x transpose y would have to be 0, which is exactly what we wanted to prove. So if it's the case that x and y form a right triangle, then, or form a right angle, then it is the case that their inner product must be 0.